Hello, hello, hello. Hello, hello. Welcome. Woo-hoo! Thank you. That's what happens when it gets all bottled up. I'm glad I got that on film, man. That was pretty epic. Scary as hell, but... Hello, hello. That's right. Little flip. So that's like 40 milliamps at most. That's pretty cool. We got our load. It's a 100-watt light bulb. Yeah. Look at that green arc. That's beautiful. The amperage got a little high there. See, that's the problem with using one of these commutator switches, is that it's not as crisp as using magnets. It's just using a screw, so you're at the mercy each hit of how hard it's going to hit. But it's fast. That I will give it. Hello, hello. Hey, hey, what's going on? So that's like 34 volts in and about a max of 100 milliamps. But it'll be like that for many volts in. So I'll put it up to 40. Oh, no, look at that. So you put the coil, you put the trigger coil off into the side, just so you get the fringe of that opening to coincide with when the switch is on. I got a 100-watt load on it. What more do you want? And you can't say that a light is not a resistance load, because it is. True, it's an LED. No, dude, it's a 1,000-watt equivalent. 1,000-watt equivalent. So 100 watts is right. This one is not a teeny incandescent bulb, dude. Oh, you want me to use a teeny incandescent bulb? All right, here, let's try this one. Sound like a plan? I don't know if it'll work, because you're right. It's a different kind of light, but still requires at least 100 volts to turn this thing on. So I don't know where you're getting that 3 watts or whatever. That's BS. Let's say at the most minimum is 15 watts. I have not tried this, and I'm kind of with him that it's not going to light up, but we're going to give it a shot. Just got to let it heat up enough. I don't know what's going on here. I just had a huge, like, epic burnout just before, like, right at the start of the show here. And there were like 12 amps going through this thing, and it's only, you know, uh, scheduled for 10 amps. All right, now the light is getting in through this. Let's turn this on and see how many volts it's going through. Not very many. Huh, I wonder what we can do about that. I have a plan, and it may or may not work, but it's going to involve removing one of the switches and just running a singular switch. Use what a stator? No, sir. No. Infinite energy? Not quite. This is actually costing quite a bit. Well, if I elevated this one and this one over here, it'd probably help out a lot. But here, let me explain how this is wired up while we're just chilling. Alright, so the little coil here and the little coil over there are in series, and they're one parallel circuit onto the switch. So this black cable is those two coils. And it's got a power input from the power supply. That's one. And then the two big gray coils, they're all 20 gauge, single file, and they're on the other one. So you got the blue cable right here on the power supply, and they're hooked up in series on another one, the yellow clip right here on the switch. And the green part of the clip is hooked to the transistor, and that's, the other part of the switch. So when that closes, you get action in the transistor, and when the trigger coil is timed right with the switch, of course you get some action. And it's amplified switch power. So what you get is the amplification of the transistor with the timing and the raw electric of the switch, which I find to be a whole lot more powerful when dealing with like torque and stuff. Like when you're witnessing the magnet push, having a switch, you see that way more than with a trigger switch, because you have to spin it to trigger the trigger. You know what I mean? So you never really see that initial kick. And I don't know, maybe it's nothing special, but we're getting the green flame. See the switch, it slips. It's a little loose. It's just kind of flopping there, and I like it loose because it'll hit more rapidly. I know that it seems paradoxical, but it does hit more often when it's a little loose. No, sir, I don't. No, I don't believe in that. Not really. You know what I mean? I believe in machines that can do miraculous things and go for a long, long time, but I don't believe in things. What's the purpose of it going forever? What's the purpose of that? Answer that one. Yeah, no, time machine? I don't know. Maybe a time disruptor. I heard that if you spin the electromagnets, you can make a time disruptor. But these are the permanent magnets that are spinning, not the electromagnets. Alright, you're going to have to show that to me. And I don't read very well, so you need to show that to me for real. I read if I have to, but I don't have to read about that. Yes, sir. Yeah. Bye. Hello. Yeah, that's my kid, and he's wanting to go outside. Now, if you go back to the beginning of this stream after it's done, you'll see what happens when the switch gets stuck. It was amazing. Things were flying everywhere because the magnetism was so strong. Oh man, speaking of axial flux, I've got an awesome project that I'm working on, and I'm dying to show you guys. It has nothing to do with this. It's actually about that big. It's cool. Yes, yes, green plasma, and it stinks like burning copper. You got to put in a little bit of voltage to get the green stuff. And you got to have your coil lined up right with the switch. You get the most of it. Here we go. Now, you can't like run your house with this because the it's actually way too much for a perpetual motion thing. Maybe you could run your house on it. I don't know. I would never hook this up to my house ever. Be like, hey, when did your house burn down? Yeah, okay, I get it. It's a pulse motor, and right now, currently, we are trying to light this light bulb, and I don't think it's going to happen because it's not letting it go fast enough to do it. But it's still working, but it's just not working well enough to light that. And it's open right now. I mean, the switch is closed, so it'll turn on if it will. All right, I'm going to turn it down a little bit and move the coil in. All right, so I got an idea, and we're going to try it. We're going to bypass the switch. This is how we're going to do that. We're going to take this clip, and we're going to clip it up here. And it got hot. See, the switch got hot. See how it's all flimsy? We gotta chill with the switch for right now. It's all right. I might have to make another one. It's cool. But yeah, that got hot and the glue got loose. Maybe I'll build it a different way this time. Huh. Maybe the... Oh, no. Haha. Maybe the transistor blew when the fire started, and I've been working with the bum transistor this whole time. Oh, I see. Something that did happen. Our black clip was no longer clipped. Oh, and we got part of the, see that wire hook to it? Dang. I hope that's not, all right, cool. Looks like we got a lot of the wires still left. Oh my God. the whole wire is like stripped of enamel. At least this outer part is. Oh my God. Oh, right now I think it's the transistor is blown. Yeah, the switch got hot. Oh man. All right, I'm gonna swap out a few of these and see. Because the switch is bypassed now. So the power is going straight to the transistor, and it looks blown as frick. There we go. That one works. I'll work on the switch later on. But yeah, I was wanting to show you guys something. It's my top that I've been working on. You know, it's got its whole like, oh, it's pretty cool. I'll show you. So this is 14 volts in. About 120 milliamps. Now the switch is not active, but it's still, I'm not going to move it because it's in a good position in case I want to leave it there. Oh yeah, wow. 30 volts, 300 milliamps, 280 milliamps. Woo! Well, each coil is about a half an inch, and then the trigger coil is negotiable. You want more energy, you go through your setup, you move the trigger coil inward. All right, let's see how much energy we're getting off the setup right now. I think it's set up wrong for how it is. Maybe not. Because I move like the connections around a lot, and I don't always move the cat bank connections, which is stupid. But all right, so this coil and that coil over there are hooked to the cat bank in the AC formation, and as you can see, it takes AC and changes it into DC. But we're only getting 45 volts of DC right now. Off of those two coils. That's not a lot. And we're putting in 30 volts and 32. You know what I think? I've got this. It's a 200 ohm resistor. Maybe if I put this on those two coils, we'll get more energy. I don't know. Hell yeah, Eric, you're great. Thank you. No, the light is not on. Sorry. I wish. I think we need to get that number up to about 80 to light the light bulb. Look at that. Look at that, man. That is fast. 60 volts. We're at 35 and 370 milliamps now. But we're just trying to light that bulb, right? So we're going to break a few of the rules. Like the 100 milliamp rule. I'm going to break that one for now. Oh, come on. All right, so it didn't light where the LED. LED would have lit right here. This is where LED would have lit up. We're still not lit up. We're at 40 volts, 420 milliamps. I'm not worried about the portal, man. I've struggled with demons my whole life. I'm not scared of the portal. Approaching 50 volts. .6 at 540 milliamps. We're almost to 100 volts. It's still not lit up. Maybe it's because it's DC. Could that be it? Oh man, we're almost to 120 volts. Why won't this thing light up, man? That's crazy. 120 DC volts and it's not lit up. Maybe it won't light up under DC electricity. That's what I'm thinking. Yes, there are diodes. Bridge rectifiers, as a matter of fact, in this cap paint thing. Alright. Not getting any light, man. Alright, here we go. We're going to move it in just a smidge. Thank you. I really appreciate that. Alright, we're almost to 120 volts. I hope that when it hits 120 DC volts, this thing wants to turn on. We lost voltage. I think the vibration's starting to catch up with it though. So it's starting to shake the pole a little bit. We all know that when that starts happening, it'll slow down. And then we want to keep it, it looks like right around 50 volts too. So let me back this out again, see if that had anything to do with it. Okay, alright, we just lost some voltage, but we're gaining now. Are we going to start gaining again? Now what I could do is I could turn the switch off on the lamp, but then that voltage is going to skyrocket, but then I could turn the switch back on and hope that the bulb doesn't blow up. No, it's not a LED bulb, it's one of those incandescent ones. I'm thinking I need AC voltage. Who thinks that? Maybe not, I don't know. It's cool though, because I'm about to switch it back to the LED, because it would be lit and like blowing up right now. Yeah, that's what I'm thinking. It's just not enough. 120 volts is not enough to light this thing DC. See, I bet if it was a LED or even a different type of light bulb, it would have been lit already. It's just, this is a different... See, that's a halogen bulb, and it's lit like a firework. It's a thingamajig. Come on, man. Can we do better than Little Mermaid? I'm throwing it out there. It all sounds like the Little Mermaid to me, the dingle hopper and the thingamajig, or whatever it is. Yeah, that's what I was thinking, that it needs to be AC. That's what I've been saying, like, virtually for the last 15 minutes. And that's cool. Alright, I'm going to turn this down. See, now I noticed when I use one switch at a time, this switch is like 500 milliamps less to run, but this switch is like 500 more RPMs than this switch will ever be. But them combined, awesome. Totally freaking cool, man. That is a great idea. I gotta give it to Mike from Faraday Research, man. That is a great idea to combine them like that. It's definitely not blown. I just turned it on. See? And that one will light up like nothing. But it takes 78 volts to get it lit. We just get to 78 in a heartbeat. Yeah. Yeah, go check him out, dude. He's cool. Absolutely. Sure. We're gonna take it back a couple notches. What's up, Josh? Welcome. So he says if it's above 100 milliamps, it's no good. And I always gotta ask, what's the end game? that that is the truth. And I'm not saying it's not right. I'm just saying it's like, see this, you know, 440 milliamps, maybe more, and that's running with just a trigger coil. But if the switch back up, you know, I'm running on less than 10 milliamps. And then you put the switch in phase, you put the coil 90% out of phase, and you get some awesome results. Talk to you later, Mike. So I got a few ways to harness some AC, like directly. Look over here real quick. This coil right here is all 32, and it can harness some AC pretty well. So like if we try again, let's put the coil up there. And that's all you gotta do. And it should light up the light, like, eventually. Yeah, motor, generator, tabletop toy, fun times. I've got two PWMs right there in the bags, right here and right here. I was thinking about running like 150 kilohertz through both of these sectors, or coil arrangements. So the two big coils are linked in series at 180, and then this 180, they're linked in series as well. And then the switches, when they're both active, are kind of linked in series as well. So you got the 180 circuit here. It's awesome. I mean, look at that. Steady, clean, no flashing. That's coming from the two big coils. Hell yeah. But you can't, it's like the switch, the way it is, it's not built, it's built flimsy, so I need to rebuild it. Try and make it a little tighter. Then it won't, what I'm saying, when I run with the switch, that flashes a lot. So it's like it sends different amounts of power through each contact, which is not good for experimentation. I need to make a little bit more solid switch, and then I think it'll be all right. It's 14 gauge, and then at the same time it's 18 gauge, 14 and 1 millimeter. The output is 80 DC volts. It's coming from this cat bank right here. But that's only these two coils. The other two coils aren't tapped yet. You know, I haven't hooked anything up to them. Turn it up a little bit. Now it's 81.2. And look at the output in the light, man. That is like brilliant. You can't get without plasma. It's like that. You can't. You have to have amps unless you have plasma. And that green plasma, it really does make the light brighter when it's running like that. It's a awesome thing, and it makes everything cooler. It really does. I mean, you can feel right around here, and you can tell right now it's not a cold circuit. It's actually warmed up, warm. I'll turn the light off just to... There's usually a draft coming off of this thing, and the draft is usually cold. like everything's cold. But now I feel it, everything's kind of hot, and even the draft is hot. You know what I mean? But in order to change that, and I wouldn't say hot, it's warm. It's lukewarm. See, you already got a little bit. But that's mainly white plasma, or just an arc, actually. Yeah, look at that. Move it off, you move it off, 90% off phase. So just 10% of this coil is active when the switch is on, okay? So you get like very little power going through the system just by manipulating the timing of both switches. See? That's legit reading. That is 0 amps right now. And we're getting an output. So that's awesome, in my opinion. Hello, hello. Magnets in the middle, yeah, electromags on the outside. Got a commutator, reed switch, and a trigger coil working together currently. See, once you line the switch up with the coil, the amps start flowing. And then you move it a little bit closer, the amps start creeping up. But see, look at how flashy that is. I don't like that. Electromagnets and switching or timing, positioning is very key. But you see how slow it's going, right? With the switch on. And that was at 75 volts. But, I mean, you get immediate light up pretty much at around 35 volts. See, now what's scary is if that switch locks up, You're at 75 volts, you're gonna see electromagnetism that you don't see every day. And everything's gonna come together to the center and you're gonna see some mayhem that you don't see every day. But I'm not just gonna let that happen. It happened already at the beginning of the stream. So if you'd like to see it, you can go back to the beginning and just, it happens in the first 15 minutes of the stream. The switch locks up and this coil gets thrown, literally thrown across the table. And this, yeah, a couple things broke, and one of the 32 gauge strands got really hot. I mean, I was pushing like 12 amps through a 32 gauge strand, and it just, the enamel was gone. Thank you, Eric. Eric the Great. Awesome, man. That is Eric the Great. Thank you, thank you. Rome Cruise. Eric the Great. Eric Cronhart. Cool. Oh yeah, man. Well, there's actually an evolution on the table. This one is a rather perfect coil, whereas its twin is a little bit pregnant in the middle. This coil is a little bit pregnant in the middle. It's a 300 turn of 18, 20, and 32, which makes it 900 total turns of 32 when you link them in series, because the current limiting limits the current to 32 gauge, but you get so much more mass um, for 32 at 900 turns than you would to get just 900 turns of 32. It's way different. It's way different. Yeah, that might be. And I got a core. It's not, because when I run the trigger strand on its own, you get none of those problems. None of them. They're just non-existent. But you run with a way higher milliamps. That's the only drawback. You can't unify it because it's so expensive. All right, this is just the trigger. See, it runs so much smoother, and there's no flashing light. But yeah, I try to make them as uniform as possible. Sometimes I fall asleep rolling them, so. So this is 28 volts with just a trigger. We're drawing almost 400 milliamps, but no flashing. It's also going much faster at 20 volts or 28 volts than it was at 70 volts with the switch on. Yeah, yeah, it is. When it reaches 76 volts on that meter right there, it's like a normal brightness. Anything above that will increase the brightness because it's on like all the way already, and it just increases the brightness. You get what I'm saying? Like it's its own thing, brightness. That's true. Oh no, not, it's not going that much faster. At 500 RPMs at most is like the differential between the two. I'm gonna find my tach meter right now, and we're gonna settle this. And then you're not wrong. You're absolutely not wrong. I just don't think it's a big deal right now. Oh man, where did it go? I don't know. Well, I want to show you guys something anyway that's different than this. This is fun, but for those of you that have stuck around, I got something cool to show you. Man, I just want to literally harm some people sometimes. Well, there's the rotor that I'm working on. The two flat ones are triggers, and there are going to be 4 on each side, but the 3 that are there now line up with these magnets on the top, and then when you spin one of them, when I'm done building it, it should rotate on its own. These are the bobbins for this thing, man. It's going to be awesome. It's going to use either a 3 volt or a 1.5 volt battery. He obviously didn't know what it looked like before. Wow, what a dickhead. Thank you. I appreciate it. Here, let me show you what I use to make the windings. And then you can just chill about the whole thing, man. I use this right here. It's an automatic winder, and it keeps it nice and tight. And I can do it pretty quick, too. This thing doesn't really go at slower speeds, but I'll turn it down. See, it is a 100-watt light bulb. You turn it down to like below 20 volts and it just goes out because there's not enough. See, there you go. So I guess we don't have to worry about it either way. No, it's from the way I built the switch, and I don't need to say it again because I've been doing this for like 3 days unabated. So that's great. You know, I've been building that top, and I've been, messing around with this thing. So I know that the flashing of the light comes from the switch and how it hits the second part of the switch. I'll stop it. I'll show you. Wow, it is pretty. See, look at that. It's all right though. Let's take the trigger strand off and run with just the switch. How about that? Let's do that and we'll see what's up. Yeah, there's 1,500 turns of copper in that. Big turns, not little dinky turns like we saw out there, but big ones. It's quite literally like almost 3 pounds of copper in each one of these coils. And they're, granted, this one's a little bit fat in the middle, but that isn't going to cause the problem that you're talking about. But I have a way to test that. We're just going to unhook the second one. We'll run with just that one. Just this one. We'll see. Oh yeah, we got to move this. See, I talked about, not doing that. That's so the switch. But yeah, maybe it is a raw electric thing with the coils being a little ununiform. Maybe it is a thing, because the switch is definitely flashing. But it's bright. Hello, hello. So the idea here is to get it so that it arcs with the green plasma a little bit, but not enough to make the switch seize up. So, I think just because of the fact that it's a screw in there that's doing all the magic here, it's a little, you know, jerry-rigged. It really is. But I think it's cool. All right, so what we want to do is we want to take this now. All right. Heck yeah. So I have like 12 pounds of copper that I'm willing to like wrap into coils, but I need to like, take my time and do it right. Because he's right. But these are pretty good coils. I mean, there's no doubt about it. I think I used my hand winder though to roll the big ones. So this is just the one coil. And the transistor amplification. Look at that. That's amazing. So now I just put the second circuit so it completes itself as well. And that's these two coils. But I love it. And you can hear it kind of going in and out of phase or frequency, maybe even resonance. I'm not sure what's happening with it, but it goes in and out, and the arc kind of moves around. There it goes. I don't have a whatchamacallit hooked up to it right now, an oscilloscope. And I don't think this meter does hertz. But if I had to wager, I'd say it's right around 300. Okay, hey man, I'm gonna give you about 3 seconds to get to your point. Yeah, conventional electricianism, I don't know if it's really what I'm all about. I mean, it's cool if you're an electrician, but you don't, it gives you no right to be rude. I mean, seriously. I'm gonna hook the other coil up. All right, wow, man, it's been really fun tonight. I even went over time by a couple minutes. I'm gonna hook this up. Right now I'm just running a bulb with it, but it's being stored and used by this cap bank right here. Boom! Next question. Screw you. Absolutely a brushless motor. But I guess this one produces green plasma. Alright, so there's two outputs from the power supply. These two coils, the two big coils are connected in series, and these two little coils are also connected in series. Then it goes through the switch here, both of those go through the switch, and it comes out to the transistor, which is fired by the trigger coil, and then it's grounded back to the power supply. So we got those two circuits functioning. The transistor is an NPN, and it's working in tandem with the reed switch commutator. Hey, B, what's up, my brother? Okay. Yes. Yes, it will spin with just one coil. What's up, Jeremy? From the D. Whoa. Will it spin with just one coil? Yes, it will. I usually use this coil to spin it because it's got its own trigger and it's got a bifilar drive coil. Whew. Can't wait to get that top done, man. That's going to be fun, especially if it ends up hitting right. Because it's like there's two trigger coils, and that'll take two magnets away. And then there's 4 coils for each trigger coil, and that'll hit the additional 8 magnets. God, that'll be so cool if it works. mm. Yeah, it's actually a lot better in here than it's been in a long time. Mm. Yeah, I don't know. I just got upset, man. I put a lot of effort into cleaning this place up. It just needs a quick vacuum. I'm almost done with the laundry. And then flat out, this place will be looking snazzy. Applications, I'd say it can charge. I think as is, it's a toy. You know, but it can charge stuff. I could probably hook a fan up to this with no problem. You know, there's probably some high voltage applications due to the fact that there's plasma involved here, but I don't know what they are. You know, power factor. Let me turn this thing on for you to 50 volts. It's 150 currently. 100. There we go. Once it turns on, man, there's like no power needed to run this thing. It is an electric motor. Well, there is a load on it currently, but it's 100 watts. Oh, man, okay. See, this is what the problem is. I keep on forgetting to move these as I change things around. There you go. Yeah, it's a DC brushless motor, and it works with AC as well. DC to turn it on, and then it's no holds barred once it gets going. You can milk AC and DC from it all day. Yes, it's got a maglev. Oh yeah, no, this isn't for an e-bike. I mean, you could modify the coils to work on an e-bike, but this is not going to work on an e-bike. Yo, what up? The only other person I know that listens to Cypress Hill. I forced people to listen to Cypress Hill when I was growing up, man. And they hated me for it. Hell yeah. Glad to hear it. So check that out, Mike. Check that out, dude. I don't even know how that's happening. Hell yeah. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Blast off. It's like my favorite song. Hell yeah. Now, if I move it to get plasma, if I move my trigger coil into position to line up with the switch, let's see it now. But that's expensive to make that stuff. It's not cheap. Hell yeah, but that cost 440 milliamps. See, it's still rearing, rebounding from that. See, look at that. You get that green stuff, but it's like it's expensive. But it is colder. Everything's cooler when it's like that. You'd think that if it was moving faster, the wind would be blowing harder and it would be getting colder. But it's actually kind of a warm breeze if you don't have the switch on. And you're just running with the trigger coil and the transistor, it gets really hot. Right now, yeah, it's at 60 milliamps right now. Thank you. Yeah, man, I found that really interesting that when you manipulate the trigger coil, if you have an external trigger, you can move it around and stuff. So bifilar might be good. I mean, you'd have to move the whole coil, all the drive and everything. Thank you. Appreciate that. Yeah, I get a small white arc with this. Maybe a little bit of greenage. Yeah, a little bit. But it's mostly white, I think. Oh, maybe it is green. Wow. It's fun messing with that thing, trying to get it like in the proper position so that when the magnet passes, you get the most rebound. That way you get more speed on the next one. Alright, so we see once the switch gets in this rhythm, I can turn it all the way up. It'll maintain lower amperage. See, that's 75 volts. And that's 80 milliamps, 70 milliamps. But when you move it like offset, like 90% off, you still get an arc and you got 0. Yes, like a guitar or a violin or a viola, the string instrument, like hardcore acoustic instrument. String for sure though, like a piano even. So what this one does is it takes the AC and DC, runs it through the 4 bridge rectifiers in the middle, and dumps it into the DC caps on the other side, and then it draws from it 1200 watts. That's what's lighting the light. Wow, I can't believe that there's no amps being drawn, and it's not going super fast, but it's like going faster than you would think with no amps. This is less than 10 amps right now, or 10 milliamps, I'm sorry. It's fluctuating between 20 and 0. He'd probably be disappointed, man. He'd be like, now you know better than to talk about turns. It's mass, not turns. And I mean, like, it's kind of both, because length is important, but you also have to know the equation for turns. You have to know the size of your axle, because that'll determine the size of your turn. And then you need to know the equivalent math for each layer. So, like, doing it by turns is really, really hard. Just throw it on a scale when you're done wrapping it. Use your turns to wrap the coil. Because you can be really exact when you use turns. But when you're done, weigh it up. Each one of these coils weighs 2.5 pounds of copper. These big ones right here. Hell yeah. The only problem is the 20 gauge. So when I run them alone, that's like 350 milliamps minimum. Now with 24 would probably be good. Yeah, lots of mass in these big gray ones. These tiny ones are a little smaller, but they got some power to them. Yeah, you gotta buy the 3 pound spool minimum, or have soldering skills. But still, man, buying the 3 pound spool is way better than buying three 1 pound spools. Yeah, but you gotta understand the mass calculation is just as tricky or as hard as the turns calculation to come out with mass. You know, if you're gonna do the mass, how are you gonna come up with that exact amount of mass? I mean, when we talk about rolling a coil like to, you know, perfection, it really boils down to, I don't see like rolling out 2 pounds of copper prior to rolling it onto your coil. I just don't see that as being a thing. If you've done that, I need you to like, yeah, 24 gauge is what I'm lacking. But I don't understand how you can wrap a coil without knowing like how you're doing it. Well, I mean, you could weigh out 2 pounds of wire, but then I mean, like, see, the only reason I would use turns is because I'd buy 3 pounds of wire. So I wouldn't be using a whole spool, right? I don't know. I just find that, unless it's on the bobbin, really hard to weigh a coil. Thank you, sir. I appreciate everybody stopping in. Uh, I want to show one more time before I go what I'm working on in my other room here. All right. So this is my top. And I can get it super spinning, you know, like where it centripetally forces itself to spin straight in the center. I can make it do that. Anyway, this is the rotor. So you got the two plastic bearings, and then this fits right on top of it like that. And once I get everything hooked up and soldered together, and I'm going to put two of the small transistors, BCE, and then two batteries on each side, fairly small ones, like the coin batteries. I got two more of the coils to wrap. These are the bobbins. Sick, man. They're so small. I'm glad I didn't break any of them just yet. But like a 1.5 volt battery on each side. And then reduce it a little bit. I don't know if this will be the final rendition, but I'm going to try and make it so. Reduce this tape a little bit. Should be awesome. Maybe. No, I don't think. you're going to be tripling. I have room to put like one more coil on there. There's room for one more coil. So there's not going to be any of that triple phase going on with this build. And I mean, I got to be able to do it with what I have currently. And this thing is still spinning. That is amazing. Thank you. Thank you so much. And I believe that top thing is going to be really cool. We'll see if it works out. If not, I'm going to keep on doing it until it works out. I might have to make it a little bigger. I mean, who knows? All right. Well, thank you very much. Peace out. Have a wonderful day. Please subscribe. Bye now.